Hi everyone, Maxime Dupuis. Today I'll be solving the Project Euler number 24 using TDD as usual. So yesterday we did the number 23 and it took us 3 hours and 22 minutes. So we'll try to be more focused today and use TDD until the end and try to do it faster this time. So here's my desktop. Number 24, as usual, I didn't read the problem before, so we'll figure it out together. Lexicographic permutations. A permutation is an ordered arrangement of objects. For example, 3, 1, 2, 4 is one possible permutation of the digits 1, 2, 3, and 4. If all the permutations are listed numerically or alphabetically, we call it lexicographic order. Alright, like in a dictionary. The lexicographic permutations of 0, 1, and 2 are these things. What is the millionth lexicographic permutation of the digits? All of those. Alright. The millionth lexicographic permutation of the digits. So if we list them all in like numerical order, well, not alphabetical, but numerical order, it gives us something like this, and this would be like the 6th one. Now we want the millionth. So first, since they give us a simple case, we can create a function, a test about this. So we could have a first test that I can think of is given some symbols, list all of the permutations, and then get the 6th one. Maybe later it will bite us because I don't know if we want to list all of the permutations of those 10 numbers, because it might be a really huge I guess solution space. But still, let's start with this, and then once we have the basic functions we can refactor them, and as long as the test pass we know we're on the good way. So first, let's create a test that given these symbols, it will output all the possible permutations, and we know that these are the only 6 permutations possible. So get all permutation, that's the right word, right? Yeah, permutation, get all permutations in lexicographic order. Lexicographic, no typo, order. So assert that something will equal these results. And as you can see, it can be just numbers because this one starts with a 0, so Python will return this. So we need to return them as strings. Let me use the correct type of quotes. Here, let's do it smart. Smart, I guess. Alright, that's the result that we're expecting in this specific order, and the function will be this. Get all the permutations, and we'll give them a list of symbols. The symbols will be 0, Alright, that will be the first test. It's good enough. Let's create the function. We call this symbols. So each of these, each character is a symbol. Get all permutations in lexicographic order. So what we're going to do first is, because we're using Python, there's usually an easy way to do exactly what you're trying to do. So Python permutations of list. How to generate all permutations of a list in Python. And of course there's an easy method like this. We'll try it, and as long as the test pass, that's implementation detail, so it's not really critical. So we'll import iteration tool, this file. Move the function in there. Source. Get in there. And we have a list. Okay, so this function from module iter tools apparently takes a list of symbols, just like we wanted, and then converts it to a list. And that's exactly what we want. And instead of 1, 2, and 3, we'll have symbols. So let's run the test, see if it works. So it does not. It returns none. Alright. What we'll do is extract this as a variable, and it will make it easier to debug the code. So we run the same test using our debugger and see what this returns. It might be that the permutation function only takes numbers. Iterable elements in the iterable, so it doesn't say that it's an iterable of integers, just of any kind of element, I guess. Permutation, okay, we can't see it. And okay, it's actually a list, like we expected. Permutations. What are the possible values? Right. Okay, that's not useful. Permutations. So there's no way to look at the content. It returns. Number of items returned is n factorial. Yeah, so when we were talking earlier about these permutations, yes, 10 factorial is really huge, so this will be a problem. There will be too many items. They are emitted in lexicographic sort order, so that's interesting. It will be easier for us later on. Unique based on their position, not on their value. So if there's duplicate in the input, it will break. But don't need to support that case. If they're unique, there will be no repeats, so that's what we are looking for. Let's find an example. Okay, what could go wrong? We go iter tools dot permutations. We look a list of 1, 2, 3. Iter tool permutation object. Have a link to your objects. Okay, it creates an iterator. Yeah, and I guess if you cast an iterator to a list, it will fix all the elements. Just make sure, open. Let's test it. Command range from range of 5. This is an iterator, I believe. Start at 0, stops at 5. And if we cast it to a list, it gives us all the elements. So something is wrong here. Permutations. Why does it not work? Let's do a little check. Just make sure that a list is iterable. Just make sure we're not going in the wrong direction. Are they or are they not iterators? Exactly my question. They are iterable but not iterators. They can be passed to iter to get an iterator. For them, either implicitly via for or explicitly, but they are not iterators in and of themselves. The function asks for an iterable. We're good. Why do you not work? It gave us expected list, actual none. This is weird. Iter tool permutations. Let's find some example. An arbitrary iterable as an argument and always return an iterator yielding tuples. It doesn't and shouldn't special case strings. I don't know what that means. It doesn't and shouldn't special case strings. To get a list of strings, you can always join the tuple yourself. try iter tools permutations of list of strings. Okay, looks like what we're trying to do. These are the symbols, and it gives, and he wants all the permutations. Sure, let's try it. Seems like there's no problem in the code, but let's try it. Iter tools permutation of the symbols for permutation and all those permutations. Print the permutation. Got 0, 1, 2, 0, 2, 1, 1, So I actually have, they're in the correct order, but we have to join them together. I don't know why it returns. My god. It doesn't return anything because there's no return. Stupid mistake. Will the test pass? It won't pass, but it actually returns stuff. Alright, we got lost on the way. Sorry about that. So now that we have all the permutations, and you can see them here. 0, 1, a bunch of things. So it's all single digits. So we want to join them. Like for permutation and permutations. Something like results, make array, and then we'll add them. Permutation dot join. And return the result in singular. Does this work? No, it does not, because we can't join it. What was in the example? Oh, join. I have to specify the string before calling join. So join, and it's an empty string because we don't want anything between the join characters. And then we append it. Right. The test pass. Now I think what we could write instead of this is return this for each permutation in permutations. Does it pass? No, it doesn't. Why does it not work? Is it not equivalent. And comments. Oh, it passed. I don't know why. Maybe because we iterated through the iterator, so now the state is like there's like a pointer in the permutations that in an iterator that tells it where the actual position is. So when we iterate it through it, it's probably pointing at the n. So the next time we try to iterate it, it says there's nothing. We're already at the n. I think at least. I guess it's still readable like this, like for each permutation in the permutations, join them and return a string. And what's great is we have some tests, so it gives us examples of what we expect it to do. So get all permutations in lexicographic order. I like to have some tests, just make sure if they're not in lexicographic order, I would expect it to return the same thing, and if it doesn't, we'll change the function, make sure it does. Alright, so as we can see, it's just the order it uses is it the first symbol and the second is the position in the array and not the content, as we saw in the doc earlier. So what we can do is use the sorted symbols. It should work. Yes. So we have all the permutations in lexicographic order. We'll now create another function. If we go back to the question, we want the some element at some position. So we'll do some test, make sure it finds the correct element here. So get I don't know, ant permutation well, it's not really useful, is it? Because we will just take the return and access the ant element. So there's no real function here. What we'll do is we'll first prove that it takes too long to create the main using this function. I suspect it will, because there will be, like, as they say, 10 factorial possible combination, like permutations. And I suspect the challenge is to not compute all of them, but just compute up to the millionth, which is probably a lot faster than, I don't know what 10 factorial is. Let's have a look at what it is. Biggest number. Oh, that's not so bad. 3 million. But that was not all of the all that was said in the doc, right? Oh, we want the documentation. Permutations. N is n the number of elements, probably. Where do you define the n? The R is the return success R length permutation of elements in the iterable. R is not specified in our case. Well, let's just assume n is the number of elements. Or 0 when r is bigger than n. Yeah, okay, it works with an r of 0. R is 0, N is 10. It does not make sense. The number of items returned. What is the default R? Oh, the length of the iterable. So we add minus R. We add six element in the iterable, 3 element. In this example, but we're looking at 10 element. Oh yeah, so divided by 1. So we got 10 factorial combination. It's not so bad. A couple millions of computation. Maybe our computer can handle it. Let's just write the test. We're in the main and we'll see. Maybe this is all premature optimization and it's good enough. So we want to have all the permutations. We can do this right range from 1 to 10 plus 1. Let's just make sure it's right. So does it work with a range of, in this case, 0 to 3? The tests fail. Does not work. Let's investigate this. Or you know what? It's not in the requirements. You can just write at the array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. These are permutations, and we'll print the millionth permutation. And we have to run the main. What's wrong? Oh, we can join. Yeah, right. It's not. They're not numbers. They are strings, symbols. So that's why the test failed. It was not. We used a range of numbers. Okay, so that was quick. Does it work? 33200. And it does not work. Maybe because they start at 1 and at 0. So this would be like the first number. So we want the brilliant one. Let's try it. 93102. Oh, you're not supposed to permit to submit another guess within 30 seconds of your previous submission. Okay, so we'll use this time to commit. Add everything and commit. It's a little bit premature, but we solve problem 24. And if we didn't solve it, we'll amend the commit. As long as it's not pushed, the rest of the team will not know about it. 74208, and it's bad. It is bad. What did we miss? Let's have a test with the 10 numbers. 0, 1, and permutations from 1 to 0 to 9. All this. Won't assert all the possible conditions because, as you saw, there are like billions of them. But we can assert that the length is, the length should be this length. Assert that the length of the permutations is this. And we'll move this in another test. Okay. All permutations in lexicographic order for huge permutations. Maybe something breaks if we have too many things here. Is that lexicographic order or lexicographical? Lexicographic order. Oh, we can use both. So we'll use the shorter one because we're lazy. Okay, both tests pass. So we have the expected number of permutations. What might be an error is 0 before 1 in lexical order. I guess so, because in this case it showed us a good thing. Alright, let's assert that the first element is basically 0, 6, 7, 9. Does it pass? It passes. So in our code, that was the 0th element in the array, but they're asking for the first one. So actually we have to do -1. So million -1. So that's a little brain fart from me here. 999, 999. Run the main. By 1 errors, the bane of all programmers. And we got it. You've just advanced to level 1. Yes, congratulations, my friend. We are not now level 1 programmers. So yeah, I'll see you for the next video.